Assalamualaikum everyone.
Waalaikumsalam warahmatullahi wabarakatuh.
Ini partisipannya masih only 7 partisipan. Macam mana ya? Kita tunggu sekejap atau kita go on? Kita tunggu dalam 2 minit ya. Bismillahirrahmanirrahim. Mungkin kita start aja ya. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Alhamdulillah rabbil alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi washabbihi ajmain. Amma ba'du. Let's we start our session this morning by recitation of Al-Quran Al-Fatihah. Okay, I would like to thank to everyone who attending this KOP Tarik talk series number 4. So this is our routine session in order for us to communicate our research among the lecturer in KOP. And I would like to also say the Ramadan Mubarak. Hopefully you will get the blessing from Allah Ta'ala. And then also I would like to request the participant to click the item link and already share through the chat. So because then we can record and also we will get the CTD point for this. Okay, for today we have two presenters, yeah, from lecturer from our kuliah. First is the Associate Professor Dr. Hamid Fauzi from Department of Basic Medical Science, KOP, yeah. And secondly, is Assistant Professor Dr. Muhammad Hassan Abdul Aziz Al Naim from Department of Pharmaceutical Practice, also from KOP. So Dr. Hamid will present for 1 hour until 11 o'clock this morning, and then we continue with Dr. Hassan and Dr. Naim, yeah, until 12 o'clock. Okay. So Associate Professor Dr. Hamid Fauzi will present, will share his research entitled The Potential of Versatility of RNA Catalysis. Yeah. And then while the Dr. Hassan Al Naim will also talk with regarding the qualities of medicine. Okay, yeah. So I think without further ado, I would like to start, yeah, from the Dr. Hamid Fauzi. So Dr. Hamid Fauzi, now the floor is yours.
Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Kita I boleh share screen.
You can share. Ya.
Oke, ya. Mana. Tak boleh lagi.
Boleh, sudah saya itu kan. Sudah saya.
Boleh.
Boleh.
Ya.
Sepertinya boleh. Sepertinya boleh.
Kejap. Stop. Can you see the screen?
Yes, I can see your screen. Yeah, okay.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Pak Alfi, for the introduction. Okay, alhamdulillahirabbil alamin. Nahmaduhu wa nasta'inu wa nastaghfiruh. Wa na'udzu billahi min shururi anfusina wa min sayyiati a'malina. May yahdihillahu fala mudhillalah wa may yudhlilhu fala hadiyalah. Alhamdulillah, with his favor or nikmat, and then we can sit together, even it's still in online, to share knowledge. Is in the meeting, the knowledge meeting. So this is actually I miss this kind of the meeting for a long time. Because when I was in the previous institution, we never have some meeting like this. The last meeting, of course, when I was in the overseas, in the United States. This is, I think, this is the good meeting to share our knowledge to our colleagues, especially in the Kuliah of Pharmacy, because this is one of the challenge for us to have fun. To explore our knowledge, and then to share to the everybody, and then so a knowledge will become the the very have some value. This is of course selalunya the meeting of this one selalunya like in the United States and in Japan, they will just like the weekly meeting. This is quite when I see the Tarik, it means selalunya mesti ada Tarik nih ya, Pak Alfi. Because this Ramadan, because now Tarik, because sambil minum, when we drink the Tarik, and then we discuss with other people, and then what kind of topic, what kind of the research that had been going, because this is important. This is also like the condition like this is like common in the in Japan, in most in the overseas country, because selalunya most of the scientists, most of the researcher, they share the knowledge during the kopi hour. When we try kopi, and then that time we have some good idea to do
next series, Dr. Hamid, series number 5, we will have this Tarik, real Tarik.
Oh, okay, inshallah.
Dari open.
Okay, inshallah. So okay, go to the the topic, because this is I want to go to share my knowledge, my experience, research on RNA, because the knowledge is actually just a knowledge without sharing, because we have to share our knowledge to everybody, because the knowledge become the value for us. This is like a money, because the money is to be a value, it must be circulate. So in circulating, and then we can increase the, of course, the quantity, the value, and then the anything that can be explored. So today I try to explain, to share my knowledge on especially on the nucleic acid research that I've been working for a long time. Since when I the first time come to Japan. This is because I just focus on the RNA or nucleic acid, especially RNA. The first one is actually regarding the RNAs. This is the one of the enzyme that catalyze the RNA, and then after that I explore to the RNA catalysis. So this is the how since I know this is not like the small meeting, because this is the meeting is come from the what we call the various of discipline, people with the various of discipline, the background. So I'll try just to explain the in general, not in detail. So what actually the RNA catalysis, what gets the important thing in terms of the development, drug discovery. So also this also can be because the RNA catalyst actually can be used as a therapeutic or even diagnostic. This is what I have been work on this. Okay, we start. This is the just back to the what we call the. I think this is 20 years ago when I just finished my PhD. This is I think all of you know regarding this project, because this project is actually the big project from the scientists around the world. How this project is very important. This is what we call the Human Genome Project. The Human Genome Project actually starting. This is I mean the idea come from the scientist is around 1989 at the time. Yeah, I mean the 89 and then start and then start in the 1995. This is when I was just graduate from my master and then the time, and then the predicted of this project is will be finished on the 2005. But luckily, because the work I mean around the world, the scientists, the project almost done in 2 years early. This is around 2003. This already done. This is even it's not 100%, but always almost this is 98%. The genome, the human genome is have been sequenced because this is. And then what related with our my talk today? This is big is you know. So you have to see what kind of information for the Human Genome Project, because this is the starting point to go to the modern of the therapeutic, the modern of the thinking regarding in terms of the medication, because from this part actually many things that we can get information, especially related to the genomic, to the genetic of the human, because you know. From this actually there is one of the information actually in our body. Actually there is that we call the especially for the people who work on the molecular biology, we know about the base pair, the nucleotide. So from this actually we seek all the scientists sequence is around 3 billion of the base pair, the nucleotide, because the molecule is actually the important thing in terms of for the DNA. Because there is a there is a ACGA, ACGT. This is the one of the base pair, and in the 4 nucleotides. This is the important one. So and then the important, of course, because this is how our body express from the this genetic. So from this one also there is information that very important thing regarding the gene who express in our body. This is around 20 until 25k thousand of the gene had been discovered, had been identified from this genome project. So it means so when we see, because the gene actually is not all from the 30, from the 3 billion of the base pair is is translated to the to the gene and expressed to the protein. So one thing from this actually after at the end actually what kind of the information yang very important thing actually, this is just how this is from the 3 billion only 1 until 1 on 5% of the DNA code to the protein. To go to the, that's why we call this is coding RNA. The coding RNA, this only code. This is only 1%. How about the rest? The rest actually 99% is nothing. At the beginning, the researcher just thinking about this 99% is like junk RNA or DNA. The junk is nothing function in our body. But that's why for this, and then scientists focus the research of for this junk. After this, of course, actually many things that even also this is back to the our creator, Allah Subhanahu wa Taala. It's nothing sia-sia. There is tak ada yang tak berguna that Allah create to us. And then actually there is a very useful, I mean, in our body in terms of the function. So this is so maknanya that's why actually our body from one person to other person, there's actually 99% is actually the same genetic, but only 1%. That's why this is we focus on only 1% who translate to the protein, who translate to our body, expressed in our body. Okay, this is the Human Genome Project. So this is just to back, I mean, the how to understanding regarding how you understanding, I mean, in work on the molecular biology. So this is the basic, the fundamental of the molecular biology. Sorry, even I am pharmacist, I mean, I focus on the molecular biology because it's very interesting regarding the how to make, I mean, the drug discovery. This is back to the basic, the fundamental of molecular biology. I think all of we know, I mean, the basic, especially for the people, I mean, for the person who come from the, I mean, the degree in the science, and then even in the sekolah menengah pun, I think ada sedikit that we call the central dogma. Central dogma, and how from the DNA go to the protein. Protein in our body, not only this, and sama ada eukaryote ke prokaryote. This is the same. This DNA, RNA to the. This is the all the central dogma. So from this, actually, the the DNA is actually, the name is genome, genome itself, and then how to. But for the modern central dogma, actually, this is not simple like this, because even like this, like the RNA also can be back to become the DNA, of course, but reverse transcription, and we call it as well. So this is actually the circulation. That's why when we study of the virus, RNA virus, sometimes like the COVID, also the possible why the RNA virus become the DNA back and then again to infect to the person in the cell. This is the. So there is many process in the between DNA, RNA to the protein in central dogma. That's why this is the one of course there is, and we call the from the DNA RNA this become the we call this the transcription. That's why there is other one of the I mean the field that we call the transcriptomic, and then the other one also there is some we call the ribonucleochrome. This is the in terms of the non-coding RNA. This is yang 98% of the RNA, and then until go to the protein, and then from the RNA, especially is we call the messenger RNA to be translated to the protein to become protein according to the certain protein. Of course, for each genome they have some certain. This is just the basic of the molecular biology. So. What actually non-coding RNA? This is non-coding RNA. Tadi 98%, because this is non-coding RNA. Actually, we call this is because of the large segment in the genome is not translate to the protein. As I said before, this is not translate. It's not become to protein, but they have some function actually in the cell. Some other eukaryote ke prokaryote. This is the so, and then they have some major role to the process, even they I mean in terms of the, especially in terms of the regulation, gene regulation, then gene expression. This is the important thing what in encoding RNA. Yeah. So, and then how this because this is the important thing of in the I mean the even in the beginning of in this beginning is actually all the scientists, this is that's junk, just macam sampah je, and then they just but try find one by one, they find actually they have some important role in the biological process. That's why that's why this is very important thing, especially for the who interest in the disease. So this is especially this related to the cancer, because the cancer always related to the what we call the DNA, because this is how the DNA replication, and especially for the cancer cell. This is the what is to the disease. Karena itu, that's why when we see that the medication for the cancer, especially chemotherapy, is actually this just analog to the structure of the DNA. Some ada there's some purine analog or pyrimidine analog. This is one of the the strategy to make manipulate the process of the gene regulation. Okay, this is non-coding RNA. So this is what we call what kind of non-coding. Actually, from the 98% of the non-coding RNA, is many things. I mean the classification. There is many things that we have can study. This is all the scientists try to find the classify because the classification is very necessary underlying the mechanism of disease, and then also to design the target, because the process, because we thought this and then it's difficult to to design what kind of the drug, what kind of the that can treat for some disease actually related with the molecular, because most of disease actually related to the molecular biology part, especially in the cell. Most of the like this. So there is a few things because selalunya classification this is based on most of the scientists just based on the because this is is very long. I mean DNA sequence. This is can be short and then the long one. The short one actually this is there is a few things that maybe you can see here in the there is some yang the common one is like tRNA, and then also maybe have you you have learned, you have heard about the microRNA, mRNA, and then ribosome. Ribosome maybe not so many people about the know about the ribosome, and then there is also ribosome. This is all the thing that I have been work on it. I have been working in the ribosome, and then I have been working in the tRNA, microRNA, ribosome, also even in the group 1 intron, and then the for the long non-coding, actually this is just a few one. But this is very long, especially the RNA, because RNA is actually unstable. So this is one is actually yang common one is actually yang ramai all the scientists focus in the antisense. This is in term treatment, especially for the cancer. Also for the what we call the virus infection. So now recently that I try to find in the some literature, most common research and focus on the circular RNA. This is also this is just find in the few in years ago regarding the another of the non-coding RNA, because one by one every year after the genome project, many scientists find the function of this RNA. This is why they get the catalysis. This is the this why this is the one of the actually cycles very the challenging for us, especially for the lecture for who work on molecular biology. In fact of the to find this is now many information regarding the circular RNA. This is related to the like the CKD with the with the liver. The kidney problem, so the CKD, and then how to treat the CKD with this circular RNA. That's many things, and so that's why we need this actually to make see the mechanism, to see how they can work, how they can be. So from this, and then the researcher or the scientist can be can design the RNA, the artificial RNA that can be used as a therapeutic agent. Okay, now go to the go to the first of course the first related RNA is the RNase, because this I work. So now this is the ribosome. What is actually a ribosome? This is the first catalytic. The RNA is defined by two big researchers. This is the Thomas K and then the Sidney Elman. This is around 1989. They got the Nobel Prize. Actually, even they start work on this RNA is 1982, but in 1999 they got Nobel Prize for the discovery of the RNA. So they said the RNA is not like molecule. just something molecule, but RNA also can be used as a, they have some function actually as a biological catalytic. This is the as much as biological catalytic. It means like that's why the name is because lalunya we always thinking the catalytic is always catalyzed by the enzyme. In the beginning, all the thinking about the catalytic is already related to the enzyme. I think all of you know the enzyme, how the enzyme work, because this is that's selalunya because the enzyme itself actually the protein, enzyme protein, because this is the amino acid, right? So from this this is very important thing, ribosome. So from this and then the ribosome, how the ribosome, how the RNA is molecule, how the RNA molecule is working as a as enzyme. They have some catalytic, they have some action, how to clip it, how to clip the RNA itself. Some other, this is the important thing of the ribosome. So this is the ribosome. So why this is, as I said mentioned before, this is the when selalunya enzyme pun is very important thing in enzyme in the beginning. I mean, a very important thing in the biological process, especially in our body. With the some problem in the enzyme, that of course our body is become a problem, and then why all the the disease also, this is because of the enzyme. So this is the the thing of the scientist. So that's why this is the ribosome, because also this is related to the to the disease, how to the name actually sometimes from the name is also we can try this. Some other this can be actually from the ribo enzyme. The ribo is come from the RNA itself, the ribonucleic acid, and then the enzyme. So maknanya the RNA that can act as enzyme, exactly same, but of course the mechanism little bit different, because how they work, and then how to, because, and then one thing, the important thing when we compare to the enzyme, of course the enzyme is big molecule, because this is composition from the amino acid, as you know, but the ribosome is very small, smaller than the, because this is quite challenge how to develop the ribosome as a therapeutic agent, as a the potential, the agent, the potential can be used for the treat some disease. This is the ribosome itself. So maknanya this is and then how? So how they work actually very simple. How the this is like because in the beginning when last time when I tried to find this is 1992 when I come the first time come to Japan. This is actually the simple one. When we see this is the ribosome, because of course when we see the from the whole the genome project and only 1%, this is actually coding. So maknanya this is this is how the code comes actually from the messenger RNA. So how to how to interrupt the process of translation, actually of course most of the disease actually, especially who related to the genetic, how to interrupt the process of the translation. Sama in virus also, through the different virus we have to interrupt the process of from the end replication. So and then from this actually how they work, how to treat this from ribosome, how to bind with the specific messenger RNA who translate to who as a code sequence for the protein. This is very important thing. So how they can just find as a complementary. This is same like because you know maybe the complementary is actually, as you know, selalunya kita complementary just thinking in the what we call in the DNA. There is some Watson Crick, especially for the person for the lecture who come from the medicinal chemistry. This is and then the ribosome, of course, one the binding, of course, with the specific sequence. With the specific, just 3 specific base. That's why this is very important thing. So and then they will be clip it, will be cut, will be with like a scissor, scissor. Just potong dia, and then so of course the process, the translation become terminate. So this is the process of the how to so mananya ada clip ada RNA, and this is how they work. Very simple. This is like same like when we compare with the RNAs. This is the how RNAs work to. Of course, the RNAs is the enzyme, because also this is the RNA. So mananya RNA, and then how this come. This is the mechanism of the ribosome. So this is as a comparison, the challenging. The advantage of the ribosome can use for the because the characteristic of the ribosome like enzyme. So when we compare with the first before, the first finding, this is the antisense, also can use as a therapeutic. But the problem is the antisense is actually this also long, very long, and then they just bind to the, but there is no cut. They just how to disturb of the translation. So mananya once they bind, they stop this. But different with the ribosome. Ribosome when the cut and then they can still work. Just like enzyme, they go and then can be reusable. Can be reusable and then try to make some reaction. You know, the reaction of the chemical reaction as it depend on the especially enzymatic. They're on of course the pH will be increase the rate of reaction, and then also some another cofactor. So this is the enzyme, and then so that's why with the small amount of the ribosome that can be used for the big, the higher of the reaction, they can be served as a substrate. What kind of substrate? So they follow, this is like the enzyme. They follow the what we call the maybe you still remember regarding the Michaelis Menten. Michaelis Menten. This is the once of the they reach the stagnant and it will be like this. But the follow of the post order reaction. This is the all the reaction that the research that I have been done in when I was in Japan. How to see the activity of this ribosome. This is the difference between the antisense of RNA. So and then how to relate, and then of course this is very related to the pharmacy, especially to in terms of the drug discovery. So this is just comparison between the enzyme and the ribosome reaction, the mechanism reaction, especially for the lecture will come from the medicinal chemistry. Know about how the RNA cleavage by the enzyme, because most of it actually this is because of the nucleophilic attack. This is because of the one actually in terms of the phosphodiester. This is the as you know in the A, this is just nucleophilic attack. So but different in the ribosome. Even it's a nucleophilic attack, but they need some metal. So metal ion selalunya magnesium, because this is also I have been work to compare which actually the metal ion very very useful in yang have some high reaction with the ribosome. This is I have to compare with the some metal ion like magnesium, mangan, yang selalu ada, but the magnesium is actually the the highest one. How to make and then how their reaction. Okay, this is also this for my PhD dissertation thesis. This is also this and then some other where it is directly or indirectly. This is just mechanism. We don't need to especially for the people just know about the reaction. This is maknanya, of course, the ribosome they need metal ion. Jadi especially for the bivalent metal ion. So but the concentration is very low. This is the compared to the enzyme. The enzyme is of course they need just selalunya just the temperature. So what kind of ribosome that have been discovered now? There is I think there is many things. There's actually even when we see yang is common one actually the tRNA itself. We know the tRNA is actually kita selalunya kalau yang from the basic of the molecular biology, what the part of tRNA we know. The tRNA function how to make as a mediator, as a adapter for the translation from the message from the RNA. Kita we know apa yang from the orang awam The public, this is from the RNA to the protein. It just adapter to, because the RNA is some specific that we call the anticodon and codon interaction with the messenger RNA. This is also, this is a ribosome. Nanti kita this is also I do this ribosome is especially with the RNA. This when I was in the United States. And then the other one, there is another what we call the ribonuclease P. This is the first ribosome. Next page, this is button. And then there is some of course splicing and sub-splicing, because you know in the process of molecular biology, actually that's why even from the 3 billion of the nucleotide from base pair, this is only 20 or 20K. So mananya there is rest of the DNA or RNA is not, I mean, to the gene. So this is the we call the other we call the process of the splicing. So this is the one of the ribosome can find is actually group 1 intron. This is the first and then the largest of ribosome. This is group 1 intron and then group 2 intron. Sorry, this I'm not just in detail. So this is and then the other one actually the hairpin ribosome. This and then the last one is actually for amarhide and SDP. This is the last time I focus in the amarhide and SDP. Amarhide now until now this is the ones of the ribosome to treat the HIV, because this is last time try to treat the HIV, because this is the challenge to, I mean, to treat for the AIDS. This is the how the person, because it's in terms of the RNA replication. So this is how this is like enzyme. Of course, when we study of the RNA, also we have to understanding regarding the structure, because with the structure we can decide. With the structure we can design what actually, because of course as enzyme must be have some active site. They pernah active site and bind with the substrate with the specific active site. They akan bind. But of course, they need the folding. They need the conformation chain to make some binding with the active site, with the specific active site. Same. This is similar with the ribosome. That's why we need to study also the what we call the secondary structure. And then this is a few of the secondary structure of the ribosome. And then of course, this is already had been crystallized. Study structure, so mananya this is and then actually what kind of how they make clip it to the RNA. So there is some amarhide, the simple one, because amarhide, because why they call amarhide, because the secondary structure is like hammer, the head of hammer, this is amarhide. And then the other one is the hairpin. And then there is some this is the simple one, and then I mean there is one, the biggest, the Lingos is actually group 1 intron and group 2 intron, and then also there is some SDP. This is the for my the SDP, actually this is my dissertation for the SDP ribosome. So this is the other, as I mean the largest the line of the group of ribosome. They call this group 1 intron splicing, because they have some function as a sub-splicing. This is the process, you know, especially when we actually from the how the I mean our genetic, and in the this is a composition between the intron and the exon. As you know, the in the eukaryote, there is a especially in the karyote. So maknanya there is some they must be, before the translate to the protein, it must be splice the intron. Dia buang, they throw out the intron from the sequencing before translate to the protein. So this is why this is from the beginning. This is they find from the tetrahymine thermophilia. This is the, I mean, some protozoa. This is they find the process of this self-splicing. So macam mana how this splicing can be done actually in the cell of the some microorganism. So actually this is the simple one. This is there is some function from the whole length of the RNA. there is some process that we call the splicing. How this is actually because of the sum that we call the at the time is we call the group 1 intron. How the process they kind just actually the same like with the space peak sequence. They find the and then they just binding with the G couple, decouple with the G, and then they try to splicing and then nucleophilic and then so. So this is actually when you see in this figure, actually this is the cis, maknanya is the cis acting. This is from the original one, and then how to interrupt, how to from the outside. Of course, we call the like the C and the picture. This is from the outside. How to we try to make some artificial of group 1 intron. This is similar to the originally the nature of the group 1 intron. So and then the treatment can be used to disrupt of the splicing. This is the splicing one. So maknanya, and then at the end, of course, this is the all the mature of the messenger RNA that can that ready for the translation. Okay, this is the SDV ribozyme that I have been studied. This is also the, the short one, and this is the pseudonode. This is the SDP one of actually this is why SDP. This is fine from the for the hepatitis delta virus. This is for the virus one. This is SDP. In this time, I tried to study about also the structure. How the maximum, the potential structure of this SDP with some specific sequence from the study. So the Hammerhead, this is also our group in Japan who work also in the sama-sama kita with one I focus in the SDP, and then my other group is almost in the Hammerhead ribozyme. This is the why the Hammerhead ribozyme, because the Hammerhead actually the smallest one. This is just around less than 30 nucleotide RNA, and this can be used. So mana is a very the chance to be as therapeutic because it's too big. It's because the RNA is actually unstable, so easy to degrade it in some certain condition. This is the Hammerhead. So and then the Hammerhead as this is this more focus for SIV because of this actually last time that's why. Last time it's easy to get a job for me because I focus in ribozyme at that time because the booming of the how people work on RNA. So last time when I try apply all the the work in the United States, many offer. Hamid, you can join this and then we have some project with ribozyme, ribozyme, and then to find to develop the agent like this I can be so this is the ribozyme because this is at the time is very challenging. Even now actually the clinical trial of this ribozyme some ribozyme already done especially for the SIV. So so this is the application, the biological application, the chemical biological application. So this is the application. This application is some actually because of based on the clipping, become the cleavage of the messenger RNA. So of course this is ribozyme. The other one there is something for the ribose switch. This is just not based on clipping, but based on the binding. But some ligand and then they can chain to the conformation chain and then the disrupt of the reaction. This is and then the other one also the as you can like B, this is uncleaved. This is the process of like the with the some modification with the how to make this from the RNA and then just add the ribozyme and then the process of the translation or the gene expression will be disrupted. So okay, and then this is the ribozyme, and then the other one. Okay, I just talk dikit lagi ini just because the okay just this is the ribose switch. This is the of course also this is the one of the important thing regarding the how to make this, but different with the ribozyme because ribozyme work as a by cleavage, but this is the analysis by ribose switch. How to make the structure is changed. This is the we call this the first the common one is actually many kind of the ribose switch RNA. This is one of the I focused last time when I was in the United States. It is actually the T-box, the T-box system in the process of in Bacillus subtilis. This is one so this is how to make as you can see this and of course this is lebih pada regulatory ya. This is the T-box regulation. So as you can see here, this is the T-box system in the structure of the RNA. This is the so this is the model of the reaction in T-box mechanism that our group in United States proposed because of the how actually the process of the translation of the process of the transform the gene expression from the gene. So as you know, this is the one of the, you can see the blue one is actually this the tRNA structure, and then this is the RNA. This is non-coding RNA. This is non-coding RNA. This is RNA. So how the system, the T-box system actually this is you know, in the translation you may know. So maknanya the tRNA will be bind with the specific codon antigen with the special specified loop in the loop they can bind, and then they can translate to with the some appropriate amino acid because for each tRNA they have each amino acid they have some specific tRNA they are binding. So this is actually for this system, this depend on the ratio of the charged and uncharged of the tRNA. So maknanya if the once of the tRNA in the three end of the they bind with the some amino acid, they will be disrupted of the binding with the position of the specific RNA. So maknanya akan disrupt. So maknanya there is no no binding, and then so maknanya all the process will be going. Will be terminate. Will be terminate. There's called termination, and then we terminate. There is no more. So, but if the low charge of the tRNA, there is no amino acid. So maknanya this tRNA, especially will be selain bind with loop and then also bind with the other radical, and then there is some conformation change in the RNA that dia akan rubah menjadi anti-terminator. So once binding, the process of the retro, the process of translation, the process of the maturation of the messenger will be disrupted, and then there is no more anti-terminator. They will stop. So maknanya dia akan tak stop ya, anti-terminator, because anti-terminate, and then the retro, and then dia akan jalan terus. This is the process of T-box. So what I study in the United States actually to find to try to this is the the one of the challenging to design what kind of as a artificial RNA to make disruption of this binding with the some we call that's why we try to create as our group. This is so this is the the discovery. This is of course this is just the simple one, how to make maknanya to make to disruption. So maknanya there is some termination of the process. So this is the model that try in our group in Ohio State. This is the one of the small anti-terminator. From this actually, I try study with the some tRNA from the Bacillus subtilis. This is tyrosine, and then try to find the binding, and then from this actually we can find the specific bind, the specific sequence from this, and then try to. So this is all the thing actually. Like this ABCD. This is the tRNA, and then try to minimum, because actually the important thing from this actually how to this ACCU binding with the anti-terminator and then UGA. This is actually the strategy of the how to as a therapeutic agent. So okay, this is the small interference. This is just the information for you regarding the clinical trial have been done for some certain non-coding RNA as a catalytic. So another thing, because I think for this afternoon I'm for this time, because the time is almost that one hour, because we need so this is maybe I want to, because this is also the challenge of the how to get the artificial RNA as a RNA catalysis. It's a catalytic. This is the the afternoon is also the chain. So last time this is a few of the, because I combine how to make the aptamer in the ribozyme, because this is I think this is for this in detail. This is very challenging, especially for the we can work with the also from the PAMTech, also even from the PAMPRED, also all the I mean the department on this kuliah. This can be work together to how to make optimal the aptamer. So from the part from the basic medical science, is how to create the aptamer that can be used for it, and then from the other PAMTech, and then how to create the especially last time I dengar dalam previous KOP talk regarding the microfluidic. This is also the important thing, because even it's expensive, actually can be used as a sensor for a diagnostic. Last time I have thinking, I mean 20 years ago to develop the microfluidic, use the aptamer. This is the aptamer, also this is the RNA DNA. I think itu saja apa for Alfie. This is regarding the sharing. This is actually many things that I can share with you all regarding the RNA as a catalysis, because this is the challenge, because this is the process. Later I will share again regarding, because the time is too much. To I mean it's difficult with talk in the various of background, but of course this is very challenging to talk and to share our so maknanya kita bekerja, because you know the great research actually come from the same discipline. The great research actually come from the multidiscipline. That's why there is why the MOSFI or the higher education, they provide for the multidiscipline is very high the grant. This is how work together to find some the target. Okay, this is that can be. So I open because this is I mean it's very limited time to I mean just cover the all that I have been work especially on RNA as a catalyst. Oke, itu aja. Terima kasih banyak. Wassalamualaikum warahmatullahi wabarakatuh. So ini soalan, and then just actually from this I open discuss, and selalunya after I always discuss, just people come to my room and then they discuss and then how to make some research together. Okay, assalamualaikum.
Thank you, Dr. Hamid. Very interesting and very informative research. Yeah, so hopefully it can be conducted in our this kind of research can be conducted in our kuliah. So maybe any questions from all of you? Any questions? Maybe I can start with my first questions, Dr. Hamid.
Yes.
So this ribosome, ribozyme, yeah?
Ribozyme. Ribosome is different. Ribosome is actually one of kind of the
ribozyme.
Ribozyme.
Any studies on diabetes for this ribozyme?
Ribozyme.
Yeah, for diabetes.
So that's why when we took the ribozyme, how to apply the ribozyme, we have to know about the first the mechanism of the disease. If we know the mechanism, actually why this actually there is potential to do the I mean how to apply the ribozyme, especially related to the of course even sekarang ini ribozyme recently lebih more in focus in the what we call for the virus infection, how to treat the virus infection, because this how to cut the process of the DNA replication, RNA replication or DNA replication. This is the I mean the purpose of the, but it's that doesn't meaning impossible to, because one is know about the I mean there is some genetic in I mean in the diabetes. That's why we can find the what kind of the ribozyme that process in the genetic part. Yes, selalunya that's why. Tapi actually this is not only ribozyme, because tadi the non-coding RNA is not only ribozyme. There is some another part, and then like circular. Circular is more maybe more than applicable for the or related with the kidney, the kidney or the cardio, the heart disease. Because why no most of the people also they focus on the mitochondria. Mitochondria, because it is actually di dalam mitochondria there is some money RNA.
Yeah. Okay, maybe from others, maybe any questions? Okay, Dr. Hamid. Salam ya.
Salam.
Assalamualaikum.
Salam.
Yeah, Prof. Hamid, thank you,
Saya
thank you
panggil
very
Pak Hamid
much
je.
for your thank you very much for your presentation. I found it very refreshing listening to your presentation, especially related to ribozyme. Do you have any idea or your own experience, as you mentioned before, you used to work with ribozyme into diagnostic? Because at the moment I'm working with ribozyme based or a modification of ribozyme that they call it multiple nucleic acid enzyme to use it in the diagnostic. Any comment from you, or have you involved yourself in the diagnostic by using the ribozyme? I think would be nice to see is how maybe next we can meet up to see how you can maybe come up with the assay for that MNenzyme or ribozyme based diagnostic.
Okay, thank you. I think this is the good question regarding the how to develop our ribozyme as a diagnostic, because most of actually we think about the diagnostic. So from until now actually ribozyme is most be more in focus in the therapeutic rather than the diagnostic, because based on the how they work, based on the mechanism of the work of the ribozyme, because this is the. But actually, there is one, the challenging regarding the RNA that can be used for diagnosis, actually aptamer, because aptamer is very specific itself. This is, I have been work on the aptamer last time. This is same like RNA, but how they work actually just based on the binding, not there is no clipic reaction. Because this is challenging, because the most of the diagnostic, they have to diagnose how to the diagnose some what kind of the specific agent in the some disease, isn't it? That's why this is the one important thing actually. This more in the most challenging is actually how to develop the aptamer. This is my even actually the ribozyme now they combine how to with the aptamer. They combine with the aptamer. They combine we call the enzyme, the ribozyme combine the aptamer. How to work with together. This is the challenging. This is possible. It's not possible. But for my opinion, or my suggestion actually how to work with the aptamer, because this many of the aptamer that now work because some of the what we call the infection of disease, we can try to find with the diagnostic. Last time actually I tried to to the simple one, because most of the like the COVID-19, because this is the how actually to make because the aptamer, this is we compare with the between the antibody and antigen. This is the how actually the aptamer, this is RNA. Tadi saya tak sempat because the time is very limited. This is I want to work to explain just special the aptamer itself, because how the process, how to, because this is like last time I have to share in the USM, and then now alhamdulillah the USM dah go with the aptamer, and then last time in UITM also there's some certain like they want to study about the aptamer, but this is time to make aptamer. So this is, where do you come from, Doctor?
I'm from Kuliah of Nursing, but in the basic medical sciences.
Basic, yeah, this is the basic medical science. Okay, this is very challenge. So maknanya aptamer, this is the simple one, because from the aptamer we can try to find the small RNA. This can be as a diagnostic agent. This RNA, but this is very challenging to find whatever this is, and then but not most of the, because the yang like ribozyme, cRNA, microRNA can be used as the biomarker. MicroRNA can be some biomarker because they just binding, how to bind with the specific and to disrupt it. Kalau ribozyme is more just kita pakai the clipic reaction, reaction, and then how to cut, how to interrupt the reaction. There is no more reaction in this is the.
Okay, so I just want to share my previous project was with a ribozyme, a hammerhead
yes,
ribozyme, where there's some modification of the loop itself, where the loop is in the loop, but they cut it into half so that it can be incorporated into the sensor, where the sensor is actually can be detected to the DNA biomarkers.
Exactly.
So that. Yeah, so we did explore that, but now working on it as well to improvise the method inshallah.
Okay, this is good. This is good because the diagnostic based on the product that clip it, right? How the biosensor detect the sensor out. That's why this is we can work together with the what we call with the person from the tech, especially from the technology, from engineering, how to develop the biosensor. We as from the basic science, just how to create the ribozyme. The ribozyme, the small, especially the amaret, because amaret is very very interesting because it's small and then easy to handle. Last time our group is to create this more smaller because it's 32 more smaller. This we call the mini zyme. Just a few of them, the mini zyme. There is from the one my colleague. This is Amontok. This try to find the amaret with the smallest of the structure. So boleh ada so maknanya so with clipping but the diagnostic is based on the product, the clipped product, how the makes the sensoration, the intensity of the clipped product. This is also can be used for
Thank you.
This is I'm very happy. This is because last time I couldn't find all the people. The researcher in the Malaysia work and ribozyme.
Yes, same goes to me. When I come back here, I'm so happy, so much, refreshing to listen to your presentation and happy to look at, your progression into ribozyme. Shama, we see you again.
Inshallah, this is okay. We can work together and then try to find and to develop the amaret ribozyme, especially for HIV, maybe for the COVID.
Shama, thank you.
Nanti I want to share that regarding the ephemer also. Okay,
thank you.
All right, welcome. Nice.
Okay, I think the time already finished, Dr. Hamid.
Yes, thank you.
I'm happy that people can meet here, and then find the collaborators here, So actually, this one is already announced to all kuliah. This talk, Tarik. Okay, we continue going forward to the next presentation, by Dr. Muhammad, Assistant Professor Dr. Muhammad Hassan Abdul Aziz El Naim, from Department of Medical Practice. Title is the Quality of Medicine, Current Research and Future Directions. So welcome, Dr. El Naim. The floor is yours now.
Okay, thank you so much, Dr. Alfi, for the kind introduction. Let me share my screen first. Okay, Bismillahirrahmanirrahim. رب اشرح لي صدري ويسر لي امري واحلل عقدة من لساني يفقهوا قولي. Today may be quite different topic from the basic medical science when it comes to maybe use of therapeutics or drugs in practice. So the title today, inshallah, will talk about quality use of medicine, current research, and future direction. So first of all, just maybe brief introduction about myself. I have a bachelor and PhD from Egypt, postgraduate certificate from Harvard Medical School, USA. I'm alumni for IIM. I got my PhD in 2018. Currently assistant professor of clinical pharmacy in the Department of Pharmacy Practice. I'm also leader for Quality Use of Medicine Research Group, member of the FIP Academic Pharmacy Section, associate member in the Malaysian Pharmacist Society, editorial board member in some journal, and section editor in the Pharmacy Practice in the Kuliah Journal. To date, I have about maybe 50 journal articles in different journals. So today, inshallah, the talk will mainly be divided into three main sections. The first section, we will talk about maybe general introduction about quality use of medicine, the definition, what quality use of medicine can be different from country to another. And we will have some reflection also on the effort done in the Malaysian setting related to quality use of medicine. The second section, inshallah, will highlight some of my group work on the quality use of medicine research. We'll share a few examples, so it will be maybe quite new for potential collaboration in future, inshallah. And the last one, we will highlight the ongoing research and future direction. If everyone is ready, we can move further, inshallah. First, quality use of medicine, usually the definition or the most widely accepted definition, the definition was already proposed earlier on by the Australian National Strategy on Quality Use of Medicine, when they define quality use of medicine under three main categories. The first one, to screen and select the management option wisely. Consider what actually the actual benefit or the net benefit of medicine when it comes to treatment of any illness, and recognize the broad option of maybe therapeutics involving medicine in treating any disorder. So selecting the management option wisely. The second one is when it deemed necessary, the medicine to be used, how to choose the best available option, how to consider all the factors may be related to the individual, the clinical condition itself, the risk and benefits, the monitoring consideration, the dosage and length of treatment, coexisting condition, and cost at various aspects. This is very important. And the third one, using medicine safely and effectively. And this actually the practical one, most of the quality use of medicine research, by somehow looking for some research or maybe research question related to this one. How maybe the safety and effectiveness of the medicine on the long-term run. From the monitoring perspective, for minimizing misuse, overuse, or underuse of certain medication, or maybe empower people to use medicine properly, maybe providing medicine information and raising awareness about the rational use of medicine in general. So this would be the three main definition or the three main aspect under the definition of quality use of medicine. In general, when it comes to research in quality use of medicine area, the research can be descriptive to assess or to describe certain prescribing pattern in healthcare settings, can also go further to investigate potential barriers and facilitators for the rational medicine use, or can be the experimental one. Mostly this one will be the level of PhD, when you design or assess impact of intervention on improving quality use of medicine and rational prescribing in healthcare settings, or as I mentioned, empowering people or promoting awareness toward the safe and effective use of medication. So the people can be more adherent, they find the necessary information they are looking at, and also improving and posting the health literacy level in the community. So as we all know that so many studies can be done on medicine according to the life cycle, but the one I can maybe show in bold here, this the one is most relevant to the quality use of medicine research. When you conduct some study to maybe investigate the extent of the rational prescribing of certain medication, to assess a patient adherence or resistance, to do comparative effectiveness and safety of certain medication, and as I mentioned, the impact of interventions and some of the comparisons sometimes can be cross-national one. Of course, quality use of medicine is a general term, and when we want to intervene to enhance safety and effectiveness, of course, this one should be based on a clear plan. Clear plan, maybe how to improve. So how to improve actually should be based on what we call key action area, or the area of focus, major area of focus, that usually problem with using medicine will come from this area. According to the WHO, maybe the document on global patient safety challenge, the global issues in using medicine, in the issue or the statement of medication without harm, where researcher or maybe quality use of medicine research should be directed: polypharmacy, high risk situations, and transition of care. What do you mean by this one? So if we go to the first one, polypharmacy, I think that data or statistics even from developed country indicated that maybe we have at least 4 in 10 people who aged 50 years or above they use at least 5 medication. And 1 in 10 of this population will have 10 medication or more. This actually maybe as the number increase, the potential problem with using the medicine, of course, increase. The high-risk medicine refer to certain medication that usually any error with their use, any error even with the regular use, can lead to significant patient harm. And this, or again, will be dependent or different from country to another. For example, in Australia, for example, they define the high-risk medicine, maybe the insulin, the opioid analgesics, the anticoagulants, the antipsychotics, something like this. The third area would be the transition of care. Transition of care refer actually to the differences in medicine use from one setting to another. For example, patient at home going to the hospital, or patient in hospital will be discharged. For example, in patient at home going to the hospital, 90% of those patients will have a change at least in one medication. The other way around, if patient coming from maybe the hospitalization finish and going to discharge, the patient, 42% of this patient will have at least prescribed one medicine that have potential problem, potential harm in a given case. This data statistics from developed country. Also, a recent analysis from New Zealand can show us that in general practice, we can see around 11% medication-related harm incidents happen. The good point that around 80% of this medication-related harm will be something we can say minor, but the rest, around 20%, moderate to severe. What the medication that mostly implicated in medication-related harm? Again, the cardiovascular, anticoagulants, and antineoplastic, immunomodulatory, and so many medication. When it comes to Malaysia, I think maybe as the disease burden and the pattern of death in Malaysia, we can see here the cardiovascular disease followed by malignancy, and also we have maybe diabetes. So this is the burden of disease by mortality. If we go maybe to take some statistics on the top 50 medication or therapeutic groups used in Malaysian settings, we can also say, we can see here medication for diabetes, cardiovascular one, calcium channel blocker, and renin-angiotensin receptor blocker, lipid modifying agent, diuretics, and all this. And the good point, actually, in Malaysia, we have maybe some sort of planning or policy to address or to maybe support researcher and support the practitioner in the quality use of medicine. One of them is the guidelines on the safe use of high alert medication. High alert medication, again, the same I have defined earlier. Those medication that mostly any problem with their use will lead to significant patient harm. So these guidelines is very maybe quite comprehensive. They identify the risk factor actually maybe implicated in high alert medication, what it takes for medication to be high risky for patients. And also they provide, this one is very important, they provide for every medication what the common type of error, what the common risk factor for this certain medication, and what are the recommendations, how we can prevent the harm can happen with this medication. This actually very good step that taken to post the quality use of medicine in the setting. Quality use of medicine in a hospital, for example, it is a team and it is a systematic process. It is not maybe one spot initiative and research and we go. Actually, it has to be a systematic process. This systematic process should identify first what are the issues, what are the concerns in this setting. As I mentioned, from country to another, from setting to another, the issues will be different. The medication will be different. So first, identify what are the issues, then what are the best practice standards we can refer to. Then we collect and analyze the data. provide some feedback, and identify and implement the change that could be done, and the monitoring how the change will be sustained in the long term. If we want to see this plan, the systematic plan, to match with the pyramid for quality use of medicine competencies, the quality use of medicine, first, it is awareness level. You can see here awareness level at the level of identifying the issue. We know where the problem, we study the problem, we aware where the problem and what the potential intervention that can be done. The level 2, going up, the knowledge and skills. When you collect, analyze data, provide feedback, this actually, when it comes to maybe prepare and the education and competencies for researcher to come and take place. And of course, with competent maybe practitioner, they have the knowledge and skills, we can maybe have the level of action and evaluation, implement the change, and the continuous monitoring for any implemented change. So I think maybe that's the first part of the talk, introduction to quality use of medicine. Hopefully by this, how at least our audience today have maybe some background about quality use of medicine, the definition, and the basic aspect of the process. In the next section, I will share some of our research in quality use of medicine, divided into maybe four main maybe focus area. The first one, my personal interest and my passion, the cardiovascular pharmacotherapy. When we do some project on the use of lipid lowering therapy and the statin and all this, we want, as I mentioned, under the research objective quality use of medicine, here we assess the prescribing pattern and also at the same time the achievement of clinical outcome. Of course, we give maybe lipid lowering therapy to notice some maybe changes in the lipid parameters and achieve the target level as per the patient condition. We can see, for example, our research, this done in the primary care settings, we have maybe in general around 87% received statin already. Appropriate prescribing was 70% only. 17.5% of patients, they already have some sort of concurrent drug interaction with the given medication. And the most important, and this may be chronic problem with statin users and dyslipidemia in general, achievement of the target LDL level. So only 37% were able to achieve the target level. This may be, again, this some sort of analysis, how the medication and the clinical outcome can be seen together for further assessment. In hospital setting, again, it is different. As I mentioned in the transition of care, usually the medication or the pattern of medication use in primary setting and hospital setting is quite different. So in hospital setting, for example, the percentage is quite maybe less than the primary care setting. And we have 1/3 of patients who were eligible to receive the medication were not actually prescribed the medication from the beginning. They didn't take the medication at least. Drug interaction a bit higher compared to the primary care setting. The drug interaction here it's about 26%. And the renal dose adjustment or some modification in the dose given should be maybe considered in about 5% of the cases. We go further to see maybe how this maybe from the prescriber perspective, from the healthcare professional, how maybe we can intervene at this level to improve further the statin. So the statin prescribing. So we have conduct one maybe educational intervention, educational outreach for healthcare professional, and we assess knowledge pre and post, and we provide some educational program. In general, our education program actually was able to maybe to increase the participant knowledge and maybe to target some areas that usually the knowledge or the clinical knowledge regarding this particular area was not maybe at the level. For example, the timing of taking statin. We have the perception that all statin should be taken at night, but usually some, in fact, some atorvastatin, for example, can be taken at any time. It is not necessary at night. This one of the point. The drug interaction and how the drug interaction is different between different statin. This also one point we focus on, and we identify actually from prescriber perspective the safety concern, the side effects as a common cause for them to discontinue treatment in a given patient. Later on, we also maybe have this maybe academic detailing program assessment or education intervention, the assessment in terms of the actual prescribing. We go to maybe the hospital settings here and there, and we see whether what kind of intervention we have done have impacted the practice or not. So maybe hopefully the percentage, fortunately the percentage of the appropriate prescribing of statin according to this working definition was actually seen to be improved after our intervention. Also, maybe in the area of cardiovascular pharmacotherapy, we have done some work on the hypertension management during the pandemic, and how the socio-demographic of patients can play a role actually for the patients to attain control and to be affected negatively by the pandemic and the hypertension control. We do some work. I think this one maybe a master student from Dr. Karim, and awareness of the risk factor of heart attack among the general public. And this our collaborative work with a colleague in Saudi Arabia, when we see in deep the statin food interaction from the public perspective, how the users of statin are knowledgeable, and maybe the information, as I mentioned in the very beginning, in the quality use of medicine, the information and the health literacy regarding the medication itself. Also, we conduct this work. This may be quite briefly our work in the cardiovascular area. Also, we have some work on the diabetes, of course. This is my second focus area. We do some work on maybe the recommendation for managing diabetes during the pandemic, and we highlight actually all the potential adjustment in the pharmacotherapy that should be considered. What are the issues? How can the pharmacist provide support for diabetes patient in general and in the post-pandemic era? Also, we have maybe do some work on the evidence synthesis regarding maybe some reviews on the renal outcome associated with the non-insulin anti-diabetic pharmacotherapy, and we were able to classify all the anti-diabetic into three main categories. Some of them actually were found to be renoprotective. They have maybe good impact on the renal outcome. Some of them had no additional risk and no much more maybe worry to use in patients with renal function. And of course, some will be associated with decline in renal parameters, and we provide recommendation for each. Also, we link about maybe the cardiovascular prevention and patient with diabetes, and how actually the awareness of patients and the perception toward the cardiovascular risk among diabetic patients. And in this paper, we were able to identify actually many knowledge gaps, starting from the basic disease expectation at the time of the diagnosis, identification of the cardiovascular risk factor on the management aspect. All these points, the patients still need support, to be able to comprehend and act properly with respect to this point. Also, maybe we found the differences. When we provide support to patients, we have also to take into account that their knowledge and perception can be impacted by the patient demographic characteristics, educational, race, age, and area of residence. All this play a role and they need individualized intervention. Also, we have some work on the proton pump inhibitor as a group, pantoprazole, esomeprazole, and all this. This our first paper when we talk about evaluation of the proton pump inhibitor prescribing among non-critically ill hospitalized patients in Malaysian tertiary setting. And in this paper, we were able to evaluate the prescribed regimen and maybe categorize them. We can see here that from the figure, about 34% only were maybe appropriate or no need to any change, or maybe was compliance with the guidelines. 19% was totally not according to the guidelines. 16% still need those adjustments, and 31%, and this is actually the main finding, was prescribed with no clear indication, no documented indication. And we come out with some recommendation that we need proper documentation of evidence-based indication for using this medication in clinical practice. And also we need for a well-defined prescribing criteria to be used in local setting, so we can improve the rational prescribing. Also, we did this one with my colleague, Dr. Aid, an evaluation the prescribing of proton pump inhibitor for maybe as a stress ulcer prophylaxis. And in this paper, we're able to show that around 30% were prescribed according to the current recommendation. But still, maybe we need national criteria to address and to highlight more on the proper indication and PPI dosage regimen for both ICU or non-ICU patients. The last point in our research, I can maybe highlight the quality use of medicine, maybe in general, when it comes to adherence and clinical outcomes, or what comes to service provision. For example, we did some collaborative work with my colleague in Egypt on assessing how the clinical pharmacy service for outpatient and hemodialysis can be of benefit. So we see here that the clinical pharmacy team were able to identify in total about 685 drug-related problems. Most commonly, the problem will maybe something related to the dose or the drug selection itself, And in terms of the clinical outcome improvement on maybe the calcium level and hemoglobin level were noted, but it is not the same actually for the phosphorus level. Also, we have done some randomized control trial with focusing on use of ondansetron for pain management, and this was one of the interesting paper, because in this paper actually we proposed that ondansetron on top of being maybe medication for nausea and vomiting, as all of us know, also it has some adjuvant or analgesic efficacy when it adds to the acetaminophen, and it has actually local anesthetic effect as well. So in this paper, we were able to show that ondansetron on top of acetaminophen only can improve actually the pain control for patient after the laparoscopic cholecystectomy. Also, we have maybe done some work on the pharmacist-led intervention. What pharmacists can contribute for patients with hypertension and hyperlipidemia? What kind of intervention that the pharmacist can do? And we characterize all the intervention and we compare. So we found maybe most of the time face-to-face counseling was the most. This paper was just before the pandemic. But most interesting, the multifaceted intervention in general were more likely to be effective. And this one, I think I will highlight later in the future direction when it comes to integrated and collaborative care. The outcome assessment for any pharmacist or any intervention will be different according to maybe the intervention design itself, the frequency of the follow-up, the length of the follow-up, the involved medication, the patient characteristics. All this play a role whether the clinical outcome will be achieved or not. I think the last one in this category, the one related also adherence and clinical outcomes, how it is impacted by the medication regimen simplification. Medication regimen simplification in general any chronic disease patient, the hypertension or even with diabetes, it is common now to have maybe fixed dose combination, for example, 2 drugs in 1 tablet, something like this, or once daily dosing, or even combination between both. So we did maybe systematic review for the literature, and we identify actually the frequency of each. And we link this one to the medication adherence and clinical outcome. So in general, medication regimen simplification is, as a strategy, it is useful, it is visible, something easy to be done. But as a clinical outcome, actually, it is not necessarily or consistently will be improved as the adherence improve, especially when the length of the follow-up is different. So I think that's all regarding the second point of my talk. So first, we covered the introduction to quality use of medicine. The first, maybe I did overview of the selected quality use of medicine research. Now we'll proceed further to the last part of my talk today. I will just highlight a few aspects regarding the research grants. Research grants that may be completed till now for myself as a principal or co-researcher. This our work on the lipid-lowering therapy. We have 2 grants and we completed this one already. And we have grants in progress, the one related to the RCVX, the Quality Use of Medicine Research Group, when we have maybe multi-component actually project improving quality use of medicine for the prescribed pharmacotherapy for patients with chronic disease, a multifaceted approach. We have, I think, I'm co-researcher in this project focusing on knowledge and practice of medication waste and disposal. This, I think, leader by Dr. Carmela and Dr. Hidayah. And we have this one on the medication regimen complexity and medication adherence among geriatric patients. The leader for this one is Dr. Aid. A few examples, I will maybe also display a few examples of my recent work. This ongoing project, the first project we are developing and implementing mobile health intervention for adherence and self-care behaviors among type 2 diabetes patients. This actually, my recent PhD student is working on it. I have also 2 research students working on mental health, type 2 diabetes, and the role of community pharmacists. This qualitative study informed by the health belief model. We have also another project on mental health and blood pressure control and antihypertensive medication adherence as a cross-sectional study. Also, I'm supervising one external student in Pakistan. He's working on maybe diabetes educator, pharmacist as a diabetes educator, how the physician and the patient perceive this one. Also, I have maybe FRGS proposal, not get funded yet, on the augmented reality model to improve health literacy and pharmacotherapy adherence in patients with diabetes. And I have maybe international research group. We do some work on the pharmacy education, the mental well-being and grade among undergraduate pharmacy students, this international work. The last part, the future direction. Actually, in quality use of medicine research, there are so many future trends. First, the integrated care. Integrated care, actually, the idea is based on when it comes to diabetes, for example, diabetes is very complex, very complex. We can see here we have a range of maybe metabolic abnormalities happen together, and we have many differences in the baseline between patients. And by time, even the situations or the clinical scenario become even more complicated when the complications start to happen. So all this cannot be solved by one perspective approach. So it needs integrated care. Integrated care refers to maybe all the healthcare professionals come and share responsibility to improve the outcome in a given case. This one interesting paper published in Diabetes Care on the aspect how the multi-component integrated care will be able to promote sustained improvement in surrogate clinical outcome. And you can see here the team change when the team may be sharing and taking responsibility to improve. This one of the point. Patient education, patient empowerment to self-management, all this maybe are aspects to improve the clinical outcome. Also, this one is very interesting for us as a pharmacist because this is a recent study done in the US. When they ask patient in community pharmacy, diabetes patient, their preference, what they prefer to have maybe support from the community pharmacist when it comes to diabetes self-management education. Diabetes self-management. So they survey the patient to see how the patients like to interact with the community pharmacist in the setting. Very interesting. First of all, maybe as initial engagement, they can be contacted face-to-face. They can maybe phone call or virtual call, as I will explain later. They prefer to have some flyers or some materials for the information. The most interesting is here. What are the topics? The topics they want to engage with the community pharmacist. Maybe many of the top-rated topics were actually not related to the clinical maybe use of drugs, or something related to the healthy eating, cooking classes, locating diabetes-friendly food, and all this stuff. So this could be a way or a platform for pharmacists to interact with other healthcare professionals. If maybe as a pharmacy, community pharmacists have also input or collaboration with dietitian and help maybe to address these needs, this would be very interesting under the umbrella of the integrated care. The second trend is, of course, the digital health. And digital health intervention for diabetes is something maybe is rapidly developing, and we have maybe many of, maybe we can say thousands of apps over there. Maybe some of them will be focusing on insulin management. You get some input, and to this the kind of output, maybe like the mealtime bolus, the parameter change, and all this. Or some directed actually to empowerment to self-management, patient education, like maybe self-monitoring, the messaging, or whatsoever. In this area, actually, I'm sharing here one of the very interesting paper. If anyone interested, I can share. This regarding digital health and diabetes, everything to gain and nothing to lose. Actually, here they highlighted what potential benefit for every stakeholder in the diabetes management from using digital health. So patient, for example, less hypoglycemia, less glucose variability, and less excess weight gain, for example. Clinician will be less time spending and less unscheduled visits, less time spent on non-clinical aspect of care, something like this. But this one actually should be interpreted with caution, because as I mentioned, in digital health, in mobile apps, for example, we have 100 and sometimes thousands of apps on the App Store, for example, and it is not all of them are of the same quality and are tested to improve any clinical outcome. You can see here the 4 key messages from this review. They highlight very maybe clearly. Although we have hundreds of apps for diabetes self-management, we only identified health outcome studies, means the app were tested to relate to the clinical outcome, only 11 of them. And of these 11, only 5 were associated with clinically significant improvement in hemoglobin A1C, was found to have some impact on the clinical outcome. And more interesting, it is none of this study actually show any improvement in the quality of life, blood pressure, weight, BMI, which is maybe very frequent challenges in any patient with diabetes. And again, as a researcher, we have also to take note that in general, most of these studies are short-term and not tested for maybe longer period, and they don't have maybe the robust maybe design in the very beginning. So we have maybe compromised quality issue with this topic. So we can say digital health is a very promising, but at the same time, it is very challenging to identify the apps that tested for a long time and were shown to improve clinical outcome. The last point in the future direction, of course, post-pandemic, we have the virtual and remote clinical care. Now, as we are maybe meeting here, we're meeting virtually. Maybe in the normal condition, we have this one face-to-face and something like this. So virtual and remote clinical care also will continue. And telehealth and telepharmacy and all this stuff will continue even after the pandemic become endemic and all this stuff. So I'm here just highlighting that remote provision of pharmacy service actually is not something new. It is more than 20 years back. Telepharmacy or telecommunication use in health has been started already. It is just during the pandemic we were subjected to significant increase in the uptake and implementation of this communication. For example, in US, for example, they highlighted before the pandemic, they have around 100 telehealth visits per month. Now, or during the pandemic, they have around 1,200 in a day. You can imagine how the increase. The issue or the point, the advantage of the telehealth, it can be customized. It can be customized to target pre-diabetes patients, so for healthy lifestyle or risk reduction intervention, targeting new patients, for example, or targeting high-risk patients according to the category. One of the maybe recent studies also show that in telehealth, for example, patients can commonly feel comfortable to using phone or any virtual platform. Some designs use telepharmaceutical care associated with free home delivery of medication. They have maybe some kind of virtual integrated care clinic, like the one adapted in Saudi Arabia. They have multidisciplinary telemedicine led by pharmacists. This one is very, very important. The telehealth or telepharmacy in general, unlike digital health, this one actually tested or maybe were able to support patients to achieve clinical outcome. So in terms of better DM control, improving medication adherence, and also maybe having achieved some objective or decreasing physical consultation from 8 visits to 2 visits over 4 months, for example, all this has been achieved. The one last point, they found actually, if the telehealth or the telecommunication was maybe done, but with less engagement time, for example, 5 minutes or something like this, this were not that effective. And actually, when compared to telehealth by other professional, pharmacist one is not also significantly different. So telehealth in general will be sufficient, whether it is provided by any of the healthcare professional, or maybe most preferably would be the multidisciplinary one if possible. We can see maybe how well structured remote care can be there. Like, for example, we can do diabetes education webinar, this done by student pharmacists in US. They structure 30-minute class on weekly basis, offered to patients with DM or pre-DM to support them. They provide this class every week, 30 minutes via Zoom. They cover content from the very beginning overview, the disease, managing diet, importance, medication adherence, and all this. They also arrange for referral services for University Family Medicine Clinic as well, and provide incentives and certification for patients who complete the program. So this may be a kind of a simple, well-structured remote intervention that can be done or adopted in any setting, and even here in Malaysia as well. This is the last point in the remote care. This may be our latest paper this year about telepharmacy. we surveyed some of the future Malaysian pharmacists, and we found maybe they are ready, they are knowledgeable and ready to uptake telepharmacy maybe more in their future practice. But the problem sometimes of the workload and incentives and the payment model also were a significant concern among the participants. So my take-home messages for this session: quality use of medicine, essential component in clinical pharmacy research in general, to optimize outcomes, the effectiveness, and ensure safety of medication. The intervention are based on a thorough examination of the sources of medication-related harm. As I mentioned in the very beginning, in every setting, in every country, and from setting to another, the sources of medication-related harm or the key action area for quality use of medicine could be different. So the examination is very important. Quality use of medicine research domains are a kind of well-defined domains, as I mentioned in the very beginning, but applications and analysis can vary depending on the priorities in different settings or country. As an educator or as an academic, I think pharmacy education is responsible to embed the quality use of medicine knowledge and application in future pharmacists to be maybe of the mentality or the mindset of a medicine safety advocates in future, inshallah. This may be this my contact for any maybe further discussion or networking opportunities for myself or our research group. This my emails and social media accounts. I think that's all for me. Thank you so much. This picture actually from my home country. I think my home is out there. Thank you so much.
Okay, thank you, Dr. El Naem. Yeah, very interesting research and informative presentation. Yeah. Maybe any questions from all of you? I think I will be the first one who will ask the question.
Welcome, Dr. Alf.
Yes. The first paper that you show to us, that you mentioned that only 30% of the type 2 diabetic patient achieve the target of the LDL cholesterol levels. Any reason why? Why is that? Because more than 80% of the patient has received the appropriate drugs. Yeah?
Yes, yes.
Why only 30%?
Yes, actually, this is a common finding actually among the diabetes patient, because to achieve target LDL and sustain the achievement need proper adherence. Sometimes the patient can refill the medication, take the medication, or refill the medication from the primary care setting, because this study was in primary care setting. So they take the medication, but they didn't take, or they take on short term, but not on long term basis.
Oh.
This is a problem. Our analysis was actually a bit long term. So long term analysis of the general achievement of target lipid level usually very problematic, because the patient to take the medication chronic long term is quite uncommon. Especially if everything is okay, doesn't feel maybe anything, because as I mentioned, statin is a preventive therapy. So the patient take the medication without any symptoms. We want to prevent something from happening. So it is not easy for patients to remain adherent to the medication on long term. I think this is the primary reason.
Okay, maybe we wait for questions from others. Any questions? Okay, then I have my second question. Sorry. Any remote with the remote clinical the remote clinical treatment, yeah? Is there any disadvantage? Maybe any limitation of that of using this remote treatment?
I cannot say general disadvantage, but in general there are essential consideration for this remote clinical care to be effective. Essential consideration. One of them is to maintain a proper engagement with the patient themselves, because as we know, in the virtual communication in general, maintaining proper engagement with the other side is quite challenging. So one of the good model I showed in my presentation, we have the Zoom video call and one-to-one session. So one-to-one session and video call, something maybe you can track the proper engagement of the patients, and you can even discuss openly the points and maybe track the effectiveness of the communication itself. Sometimes as a group, or just a telephone call for less time, this was not found to be that effective. The patients can maybe respond to the call, okay, receive the message again, and in action, nothing much improvement can be achieved. So I can say, as an essential consideration, if we go for the remote clinical care, it has to consider the structure itself, and has to consider the proper patient engagement in the plan of action that have been agreed in the session itself.
Okay, thank you, Dr. Naim. So
Most
any other
welcome.
questions? If maybe I'm the only one who asked the question. Okay, no problem. Maybe
I think everyone is tired. 2 hours in fasting, listening for
fasting. Yeah. Inshallah, and in next session we will have the now a real
yes,
Tarik.
celebrating inshallah.
It's already open. Yeah.
Very sure. Inshallah.
Okay, thank you, Dr. Naim.
Thank you so much, Dr. Assalamualaikum.
So thank you for everyone. Yeah. So we are come to the end of the sessions. Yeah. So let's we end this session with the tasbih kepara and in the session of Surah Al-Asr. Subhanallah wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Okay, thank you. Yeah, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.